Number 6. Two spherical objects have masses of 8,000 kilograms and 1,500 kilograms. Their centers are separated by a distance of 1.5 meters. Find the gravitational attraction between them. We know that our formula for gravitational attraction is Fg equals Rg times m1 times m2, all divided by our radius squared. In the problem, they give us a mass 1 of 8,000 kilograms and a mass 2 of 1,500 kilograms. They also give us a distance, which is our radius, of 1.5 meters. And we know that our gravitation constant is 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. So we have all the information we need to plug into our equation. So if we plug in, we have 6.67 times 10 to the negative 11th multiplied by 8,000 kilograms multiplied by 1,500 kilograms, and then that all gets divided by our 1.5 meters that gets squared. So when we plug this into the calculator, we end up with a force of gravitational attraction of 0.000355733 newtons. Or if we convert it into scientific notation, it's 3.56 times 10 to the negative 4 newtons. If we move on to number 7, two spherical objects have masses of 7.5 times 10 to the 5th kilogram and 9.2 times 10 to the 7th kilogram. Their centers are separated by a distance of 2.5 times 10 to the 3rd meters. Find the gravitational attraction between them. Just like the last problem, we're using Fg equals gravitation constant times mass 1 times mass 2 divided by our radius squared. Again, they give us information in the problem. They tell us that our mass 1 is 7.5 times 10 to the 5th kilogram. They tell us that our mass 2 is 9.2 times 10 to the 7th kilogram. And they tell us that our radius is 2.5 times 10 to the 3rd meter. And again, we know G is 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. So again, if we plug in, we will get 6.67 times 10 to the negative 11th times 7.5 times 10 to the 5th kilogram times 9.2 times 10 to the 7th kilogram, all divided by our 2.5 times 10 to the 3rd meter that gets squared. Again, when we plug it into the calculator, we will get a very long decimal. So our answer that we get is 0.000736,368 newtons. And again, we can convert it into scientific notation, and it would become 7.3 times 10 to the negative 4 newtons. If we move on to number 8, two spherical objects have masses of 8.1 times 10 to the 2nd kilogram and 4.5 times 10 to the 8th kilogram. The gravitational attraction between them is 1.9 times 10 to the negative 3 newtons. How far apart are their centers? So here we're looking for the radius because they're asking how far apart are their centers. So that is referring to our radius. So if we look at our equation, we have Fg equals G m1 m2 divided by our radius squared. We know the shortcut that we can just flip our denominator by what we had solved for. So we would end up with our radius squared equals G m1 m2 divided by our f of g. Now, we don't have r by itself because it is being squared, so we need to square root both sides in order to get r by itself. So then we have R equals the square root of G times M1 times M2 divided by our force of gravitation. So at this point we can plug in because we have our two masses listed in the problem as well as our force of gravitation. So if we plug everything in, we have 6.67 times 10 to the negative 11th times 8.1 times 10 to the second times 4.5 times 10 to the 8th divided by 1.9 times 10 to the negative 3. And when we put all of that into our calculator and then we square root the problem, we end up with a radius of 113.12 meters.